Hi,
Hi.
everyone. Today we're gonna host Netanel again. Today we're gonna talk about distributed stuff with Redis, and I'm here more in the listening role from now on. And Netanel, take it away.
Before we start anything interesting, there's a very boilerplate here. Do it in once. I could just read the code, but if I curl, you could see I got this world response from Redis, and that's all. I don't know if to call it distributed. Maybe you'll give me your take on it once I finish describing what we did exactly. Uh, in my job, we recently publicized like a large language model, 7 billion parameters, and we served it as part of a demo publicly. So anyone who wanted could go to it. And part of we decided that something we want to do before we make it public was somehow to control the traffic to the model. So, the model was hosted on our inner Kubernetes cluster, and then our fast API service was used as a proxy to the model, obviously. And then we had to decide how exactly we want to create this kind of load balancing thing. And I don't know how many of the listeners will be full stack developers, but usually what people want is good enough. So we're not trying to solve like a distributed denial of service attacks on a global scale. We just wanted something that gives value, and I'll explain what we decided to do. Eventually to get there. So there's like a small GUI that allows you to input a prompt and then get the generation back. And like I said, it was open to the public. And we wanted something that would prevent someone from waiting for 4 minutes for a response. We wanted like the response time to be, let's say arbitrarily now, no one has to wait for more than a minute to get a response. And then the trade-off is that if we think that the API is going to take more than a minute to return a streaming response, basically to return like a 503, a service unavailable. And then the way we implemented that is a queue on Redis. We decided to go with this type of model where we decided what threshold we consider to be if there's a certain number of concurrent requests to the model at any given moment, then the model is considered busy. But this is a busy state, so it remains busy until the number of concurrent requests drops back down to another arbitrary threshold. Why Redis? Well, first of all, the Fast API is not a single pod, it's a deployment, so it can't be handled in memory or in any other way like that. We needed some way to have a synchronization, like hard synchronization between those whatever 3 or 4 pods that were handling
The request.
requests, like just a shared state between them. And why Redis? Well, Redis is fast, and we already had like the Redis all set up. We had like the master and replication on each Fast API pod. So we had all the infrastructure to get it ready, and we knew that it was there was not going to be like very complex state. So it's very kind of easy to handle that in a key value store the way that Redis allows you to. So that's the general way that we decided to solve it. And I'll just put in pseudocode. So busy threshold, let's say that it's about, let's say 200 requests. So if we reach 200 concurrent requests, all the next requests need to get a 503 until it drops below another threshold, which let's call it 150 for now. Okay.
Yep.
And then very simply, when we receive a request, we have to do all this managing of this state. So first of all, obviously we used some queue state, or not obviously, because there are different ways to solve it, but we used a queue state. So basically a counter, right? So this counter, which is saved in Redis as a string, but that's implementation detail and it's not interesting. It keeps incrementing and decrementing. So it receives an increment, like what's it called? Command when a request starts and a decrement when it ends, right? And in Redis, increment and decrement are atomic operations. Okay, that's important to know. Basically, the queue is locked
Yeah.
while the increment are happening. And then in order to have this type of model, you need a busy state, right? So you need a bool that's either true or false, because otherwise there's no way for the service to know if it's in between these two thresholds. So Q, whatever, doesn't matter. 50, and then busy, true or false, and these two thresholds. And that's basically it for the state that we were managing for this queue, like structure, I guess. And then, well, we hit a couple of problems, basically. First of all, yeah. So it was very important for me. This is more of an engineering and less of like the distributed part. But if I go back to this code, it was very important for me to understand how I can do this asynchronously, right? Normally in our API, we don't really care if we're doing async or sync requests. It all just kind of works. And if we have an issue, then we solve it. But since I knew that every single request, the way that I modeled it, like I said, we didn't have infinite time to solve this. So I had to, kind of like scramble and put something together to get it working. But let's try to write the pseudocode for the request. Okay. So app.get/generate, right? And then we have this Redis, and let's say we get a prompt. This is the way that we did it. So embed true, which is a feature of this API, which is cool. So we get a JSON request, and we get a prompt, and we have to return just. Let's ignore streaming for now, but we return streaming response. Let's just say we get a prompt and we return the full response back, and then let's put some fake generate thing here.
You probably want that to be async.
That's true. It's true. Async def generate, and then we do return loose and nated prompt.
Yep.
Okay.
Yeah,
That's
it could have been streaming also, but for whoever's watching, the difference between streaming and not streaming is just yielding like sub parts of this string, and then on the fast API thing, all you gotta say is say streaming response and give it the generator, like the Python generator. More or less.
That's not necessarily that simple for reasons of implementation details, basically. So
Okay,
everything
yeah,
that I
but
can say is it like the way that we accessed this model pod is we used HTTPX, right? And then you create a request, and HTTPX returns some type of response that it knows, and you have to like model it into a streaming response that FS API or Starlet, which is what
yeah,
runs under the hood. And also, since we have these, if I go back to the queue, we have these Inker and Decker.
Decker. Yeah,
And so Inker has to happen when you start the response. Decker has to happen in pseudocode, like in a finally kind of,
yeah,
right?
yeah.
But the way that you do that in Fast API is using the background tasks, or that's the way that we solved it, basically. Because
Okay.
you don't want to decker when the streaming response returns. You want to decker when the streaming response ends. So when the whole HTTP connection closes, and background tasks allows you to do that. But I digress, basically.
Yeah.
But it is generally like in pseudocode, you basically do return streaming response, and you have some generator. Is that what it's called in Python? Generator, that like an
Yeah.
async iterator that yields the parts of the generation, basically. Okay, so we do return await generate and prompt. Nice. It's hallucinated, which is what everyone wants. So
Yeah.
that's good. Yeah. Okay, so now we have this general structure, and then let me just write out in pseudocode kind of what we did, and then we can talk about different aspects of it, and also the first problem that we ran into, which we did basically assume would happen, but whatever. I mean, part of the problems that we ran into was in the starting, our incur and decker weren't set up correctly with the background task. But that's like a bug in our implementation and not in our algorithm, right? So,
Yeah, but I'm quite sad that I didn't internally I put my own prediction that you obviously you misimplemented the incur and decker things because it's really hard to get right on the
oh
first.
no, eventually we got it right. Eventually we got it right.
Yeah, I know.
Uh,
What I mean is, it's hard to get it right at the first shot. Incrementing and decrementing atomic. Like once you go for atomics, everything is harder, basically.
yes, that's true. So we had a bunch of things here that are not atomic, but not because of Redis, but because of our algorithm, right?
Yeah.
Because of the way that we wrote the code.
Yeah, this is what I mean. But basically, like when you're given atomics, it's really hard to like completely behave correctly on your side with the atomic things.
Yeah, exactly. So we have this await generate, right? Before that, we want to run an incur, right?
Yeah.
After it, we want to run a decker, but how do I do that? There's a way where in
Try
FastAPI you could
finally.
say,
You
give
you could
me
you could literally try finally over the return await, and it would work as you would expect.
the try finally, should that work? No, but that's not whatever. Like I said before, because generate in our real code returned a streaming response.
Yeah, that doesn't work as you would expect because it needs to return. You need to yield all of
Needs to
the.
actually return. So
Yeah.
exactly. So
Um,
the way that we solved that was just being kind of smart alecky with the background tasks,
yeah.
which is fine. I'll just show that here because it's not a big deal to just show how that looks. Uh, right. So FastAPI has uh, this neat interface where you can do this. So we say instead of returning the response, we await generate, return response later, obviously. And our final code ended up looking like this, right? So we first incur, and then we got this wrong too because our decker was after the await generate when it really had to be here. So we did tasks dot add task, and then let's say decker. Okay.
Yeah.
And why? Because generate may fail, and then decker will never happen. So you have to schedule the task before you actually make the call to generate. So this is what it ended up looking like from the generate side, right? Okay, so then if I go back to our queue implementation, we have to do all this management basically to check if we're busy, if we're not busy, should we be busy? If we are busy, should we be not busy, right? So every request needs to check this basically. And that's the point where the atomics kind of falls apart, really, because you have a race condition here, like whether or not you want to or not. Because I didn't look into, I don't know, maybe Redis has the way to do transactions, but I didn't look into how, basically. So I didn't lock the whole state for every single request. So obviously, that's an issue. So if we go back to our code, we basically need to ask for every request. Let's create this function that I had in pseudocode, basically like bounce if busy. Okay, so
Yeah.
bounce if busy either returns literal true or it raises. Assume I have
A wrapper
Redis
around the
user.
Redis. Yeah. Whatever.
Exactly. That's what it is. And then we have model is busy. Model is busy is basically,
Yeah.
oh,
An
wow.
exception. Yeah.
Okay. All right. That's fine. And then, so first of all, we had this way where we can define if it's indefinitely busy or not. I'm just going to delete that. Okay. Because it's not interesting right now. So, okay, does the busy queue exist, right? So like we said, in order to manage this queue, we actually need a busy state. It's not enough to have these thresholds and the queue because it has to stay busy until it reaches the unbusy threshold. So if I go back here, we could ask, okay, does this busy key exist? And let's fetch the queue length while we're at it. Okay, so if the busy key exists and also the queue length. So if we know that we're busy, if we know that we need to be unbusy because we were busy, but we reached the unbusy threshold, then delete the busy key and return false, right? Else, we know that we are busy and we're supposed to be busy, like my comment says. Then just return raise model is busy, which is a 503. Else, if we're not busy, okay, should we remain unbusy? Then we return false and we can continue on. Otherwise, we set the busy key and then we raise model is busy. This is the whole logic basically for this model. So if we go back here, we just call bounce if busy. And then that's basically it for the pseudocode for this. But we can get 1,000 requests at once if we're very lucky. Then you can imagine that, they all get to this code basically at the same time, and they all get in unbusy, and they're added to the queue, and then you can get your queue being filled up immediately, even though you've reached your threshold theoretically. And we just kind of said, well, there's nothing we can do about it right now. We didn't have a better solution that we were considering then. If I want something from this code review, it's like a cheap synchronization mechanism. And when I say cheap, I don't mean latency. I mean development time, where I don't have to invest 2 days in writing amazing tests or something. Just like some primitive, some data structure, some way to synchronize all of this, which gives us kind of like perfect or almost perfect queue management and gives us the feature that we wanted.
Okay, so first of all, like the fact that you're doing low-level atomics is obviously a signal that you are going to leak some decrements or increments. And since you're doing the probability of the increment failing and the decrement not failing is is extremely low, then you're going to always ratchet up in terms of incrementing. Implementing your own distributed queue it's kind of a bad signal, because there are task queues that you could use, and then you could literally just use some job queue, and either prefect or RabbitMQ or whatever. You've got there's prefect is very cute. I personally really love 0MQ, but it is really low level as well, so I would not recommend it usually. RabbitMQ, as far as I know, is just good and working. Sometimes I just submitted things to prefect, by the way, and they just sat there while the machine was idle and then just started executing later.
That's not good.
Yeah, this is why I'm saying maybe slow. I don't know if RabbitMQ is just right, but it is basically also the more Python oriented task queues like Celery, I think, which might be useful here. But basically, the fact that you're doing your own synchronization is just it's a big no-no, basically.
Let me defend myself.
Yeah.
I didn't know better, and also there was no time.
Sure. I'll take this argument.
Okay.
So apart from that, if you do need to go rolling your own basically transactions, then just use something that does transactions for you. You could literally just use a SQL database as your transaction thing.
Do you know if any of these can they use Redis as a backend?
So I'm pretty sure some of them actually use Redis as their backend, not Redis, not 0MQ. 0MQ does not have any brokers. Your 0MQ is without there is no broker. But Celery, I haven't used Celery RabbitMQ. I have used RabbitMQ in production, but I wasn't like the one in charge of, on top of it, so I wasn't like deep in the details of like yeah, like just use, yeah, stay away, like lead, yeah, sure, whatever. But you could
By the way,
like
do you see my ligatures here?
yeah, I do.
Yeah,
Um,
I didn't know about this until I started using Fire Code last week.
oh, interesting. I don't know. I don't get like I don't care so much for whether your font is with ligatures or not, but
Yeah,
like
whatever. It's
but
not important.
basically so like if you want like to roll your own transactions, then just use something that does transactions, like use Postgres. It's going to be fast enough. It's going to like transact on a small table, which means it will stay in cache. It will stay like warm. It will probably just be, like few milliseconds, if even less. There's not a reason for that to be like slow,
Hmm.
basically. Especially if everything is like co-located in the same data center, which I assume it is.
Right. So, there's this stream is kind of a game between what I actually had to do and what would be done ideally. So I don't think we would include Postgres because we just don't have Postgres running as of now. So that would not be something that I would include for just a demo for transactions. I would probably go with something whose backend is just Redis. That would be my first go-to, I
So
assume.
so
Yeah.
as I'm saying, like basically just let someone else do the hard atomic thing, and then yeah, like it could be Redis under the hood. But what I mean is basically like not invented here. Like you shouldn't atomics. Let physicists do it for you. Yeah, I mean there like I have never had a good experience with trying to roll my own like atomics over something that has latency and it is like not literally on the same CPU. And even if it's on the same CPU, it's hard to get it right.
Yeah.
Uh, so um, yeah, I would not just like not recommend it. It's not that endorsed by Sooth. I'm okay with this. I approve this message.
Mhm.
Um, so yeah, just because of that. Like on the Python side, I think like basically once you've got like you could have also like managed that like as a context manager sort of or whatever
Mm.
like the and then you could basically like exit and return like like whenever that doesn't really matter. Also, it is what I'm saying is basically there are ways for you to basically yield all of the like exhaust the like your async iterator and then decrement just the same.
Mm.
So you could literally like wrap the yield in a try finally and then finally decrement. Like everything should work. Like all of the approaches should work like in terms of like decrementing.
Mm.
Um, but like I'm not. I haven't used the background tasks
Mm.
that much, so I don't know what are the trade-offs or like what are the like merits. So they might be like a good approach. I'm just not familiar enough to like use that compared to like just a try finally in terms of like Python.
No, but like I said, that's not an option for me right now.
Yeah, I know.
Because of streaming responses.
Yeah,
It's
I
like it's
mean,
not viable basically for me. Um,
so what I'm saying, it is viable. You could literally, you could say try, like literally, if you write try, indent your generate, or like leave the inker and decker alone for a minute. Put them outside of the body loop. Just
okay.
let's do that later. So you could say now async for snippet from generate. Uh, yeah, whatever, like chunk, basically async for chunk in in generate.
In a weight generator, how does that?
No, just generate because
Oh, I see.
you generate what yeah function call because that this is a function that returns. Okay, generate is an async generator function. It is a function that when you call returns to you an async generator. And
Right.
that generator can be like you could yield elements off of it by calling its dunder a next. method, basically.
Right. So you're consuming the generator using async for, which is
Yeah,
a Pythonic syntactical way to consume generators.
yeah.
Okay.
Yeah, and now you could yield the chunk. That's it. Um, and by the way, there is like on synchronous generators, there's a really nice way to do that, and that's called yield from, and we don't have that syntactic sugar on async generators. And then
Okay.
you could just say finally Decker.
But I don't know if Fast API, well, that was pretty cool that it did that automatically. I don't know that Fast API knows how to deal with this.
Of course it does. Of
Of course it does.
course it does. I mean,
Okay.
the only thing is that oh, so like one complication is that basically you are returning the streaming response and you're giving it the function, right?
Right.
So the decker must happen in that function, but like basically you should extract this yield like this transaction, this non-transactive transaction.
Yep.
So like the inker decker and this async for thing, you basically just need to wrap that, and that is your like actual generator.
Oh, okay. Yeah.
And that's it. And then you could return a streaming response and not think about like your inker decker anymore.
Hmm.
And as long as your Python runtime doesn't crash, you are okay.
Right.
Yeah, I mean, which like on Kubernetes with pods, you should like you could get like an out of memory and like be very sad. Um, so you should also like just know that like this does not solve leaks completely because like basically this is still fallible.
So I can get into, okay, having said everything that you've said about the way offloading the atomic and transaction logic like off to something that does it um, for you, but that's not fun. And I think the point of
Yeah,
a stream is fun.
yeah,
So let's try to think of a way to model this in Redis in a like ignoring the fact that there are libraries that do it for you. Just like I said, cheap, like from a development perspective.
yeah. So like it is cheap just because you don't need to maintain that for more than like a month.
Yep,
Um,
exactly.
so like in terms of like doing it more, let's call that I think like fast, not cheap, basically. Because
Okay.
yeah, I mean like quick and dirty. I think like maybe even a better way to describe that. So like in terms of quick and dirty, I think first of all like this solution like kind of works as you can see uh,
Yep.
because it is right now live in production and it is serving your users, which means
Yep.
it isn't like that. It isn't too bad.
Yeah.
I mean,
Well, it doesn't leak like the leaking is so if I go back to the way that it was, I don't want to do that, but whatever. The leaking that it happened doesn't happen anymore because at least I account for like pretty frequent errors that can happen in generate. And assuming that I could manually go into Redis once in a while and just put 0 in the queue.
yeah, exactly. So this is basically usually like the patch to like solving this is have you tried turning it off and on again? Basically, like, you're just basically hard resetting the queue, and
No, but I have a much easier solution if you want to hear.
okay.
Okay. Instead of maintaining a queue, a number,
I mean, yeah, first of all, like the fact that you're maintaining a number is like this is the really bad proxy for like the queue itself. But basically, whatever.
mhm.
Yeah, go ahead.
Okay, instead of maintaining a number, what I do is I create just a UUID for every request. Okay, some hash.
Yeah,
And I push that
a
into
list.
Redis. No, into Redis.
Oh,
Like,
just as a key. Okay,
yeah,
okay.
whatever. And then, since I create it in the same context, when I delete this key, then, I just use I create the same key, basically.
Yeah. So just use a TTL and that's it.
Exactly. That's the solution.
Yeah, yeah, yeah.
Then, it can still leak, but in 5 minutes, it doesn't matter anymore.
Yeah.
So
Yeah, basically TTLing is a really good way to like do a task queue, basically. But this is you are now like discovering basically how to do task management on
yeah.
over Redis very slowly.
Hmm.
By the way,
Not very slowly.
not very, yeah, but like you're discovering step by step, like whatever, like the things that people already discovered and then built like products for you. Um,
Yeah,
so
I think that's a great way to learn, especially
yeah,
on your users in production
yeah,
live.
yeah.
Yeah,
Like I'm okay with that. I'm okay with like experimenting on non-important, non-core essential business things like on users. And I
it is
know you,
kind of
I
important
know.
and core essential business. So,
Uh, yeah, whatever. You can claim that.
Okay.
I'm not gonna argue.
Mhm.
The thing that you are going to discover is that some things. I mean, Redis specifically is very good at doing that, and that's why it's a good thing that you're using Redis. But if you would have done that in Python, there is a scenario where you get an accidental quadratic performance curve of the dictionary if you are pushing and popping keys off the dictionary.
Oh,
Um,
but I
yeah,
guess maybe I didn't say, but since we have several pods running of the API, that's not an option
what do you mean by that's not an option?
because you can't maintain a dictionary
Yeah.
across
Yeah,
three pods.
yeah. That's
Yeah.
what I mean. Like the fact that you're using Redis saved you from the accidental quadratic thing that if you that just had like an API server that stores the state of all of the live requests, that would have
It
hurt
works.
you. What?
Yeah, like
I
in a
mean,
dictionary.
yeah, I
Yeah.
mean, by the way, like Redis is now quite equivalent, like usually to just a TCP server on Python with a dict behind it.
Yeah, I thought it's really like I think it does like very complex things though. No? Or maybe I'm wrong. Like,
So it used to be complex. Some things that Redis does today is like quite trivial nowadays. Um, and I mean, like people didn't know how to write good dictionaries as they do today. Like the fact that we've got like the dictionaries of Python and JavaScript that are like extremely fast and memory efficient in terms of like being that like they are really good. Like the fact that like, we've got like garbage collected system languages that have these like good like really performant dictionaries is quite amazing.
I actually think that I haven't heard memory efficiency for JavaScript dictionaries, but I have heard it for Python because what's his name? Raymond Hedinger, like works on it for years, basically.
I mean,
Uh,
like
they keep packing it
yeah,
into more
so,
yeah, more and more.
yeah, like basically the Python ecosystem is like really focused, laser focused on like making Python faster in the
Yeah.
past few years, and like you've got a lot of like very nice YouTube talks on how people saved like 6 bits off of every Python object, basically because they're doing like some kind of like bit stuffing that's like really neat sometimes. But
Yeah.
basically, that means like every time you save like like 1 bit on a Python object, you save gigabytes of memory transactions worldwide, basically.
Yeah, it's pretty crazy. Like
Yeah,
the upside is crazy.
yeah. But what I mean is basically that today you've got like a really solid dictionary, like a really flexible and fast language, and like that's built on top of like a really good dictionary. And Redis was written where when there was not a lot of that. So today, what Redis does is mostly like the core of it is mostly like trivial stuff, but it does
Mm.
have, of course, like a lot of like really good features around like the core KB store. Like the fact that you've got like this atomic thing is not very impressive when in Python everything is atomic.
Mm. Yeah, so the reasoning that we went with Redis initially, we probably would have done so anyway. But since I knew that Inker and Decker are atomic, like I knew that you can't it like as like clownish as this function is, if there's not an atomic increment and decrement, then you're fucked, basically, I
Yeah,
think.
yeah.
Yeah.
Um,
So
so yeah, like the fact that you've got like a distributed atomic is something that's very important. as I
Yeah.
said, like any database basically provides you with that. Like because like you've got like KB stores, and then some document databases, and then on top of that like relationals, basically in terms of like supersets of functionality. So
Yeah.
like on top of the atomic KB store, you've got like as I said, like go with the transaction if what you're doing if you're aiming to basically do two things, two atomic things one after the other, you gotta have like a critical section basically.
Yeah.
And by the way, you could of course you could spin lock basically and do that, but and as long as and that actually could solve you like this thing where basically you've got like a semaphore of size one, um, which says like let's only one thread of execution across all of your four servers basically catch that semaphore, and then all the others are basically spin locking until one of them like until you're done asking all of your like weird questions. And
Yeah.
then you return back the semaphore, and then basically yeah. So
Yeah, I was wondering what kind of performance penalty I would hit if I did something like that.
So it's all about like in terms of like locks and spin locks. By the way, like talking about spin locks in like a distributed sense is like nonsense. But like spin locks are reserved for like garbage collectors and like really high performance things usually. But
Yeah.
high performance like on the same device kind of things. But you
Hmm.
could like fake spin lock on something basically.
Like I also assumed in the back of my head that like Redis itself, do you see my screen?
Yeah, I do.
That like Redis itself might have some locking
So
functionality.
so basically, I think that the like
There we go.
first of all, like this like true distributed locks don't really exist. But
I mean lock because Redis handles, well, it's like a
yeah,
locking abstraction where Redis is like, oh, believe me, what I'm doing is, um, uh,
yeah,
it's writing code for me in the back. It's not like they have like hardware locks on
yeah. This is
uh,
what I'm saying. But basically, like the fact that do you see this sleep thing?
yeah,
So I think this spin locks for you.
is what?
Uh, I think this one spin locks for you.
Yeah.
Um, like we could like read into the implementation of that, but basically it has to repoll the state of the lock, which is probably like some kind of like number, basically
Yeah.
stored on Redis. And this lock, yeah, like this would like do the critical section for you. And I claim this is not slow in terms of like because you do get 1,000 requests concurrently. And it is really important that you're going to like know when you're busy or not.
But
And
my issue is with this locking is that I think the code that is executed between the lock and like acquiring and releasing the lock is Python.
so what I'm saying is, first of all, like that you should try to minimize like the critical section to be as fast as possible.
Right.
And usually, especially when you've got like you pretend you've got the lock, you could like do maybe less atomic operations now.
Yeah.
Um, because you could like basically just like incur something, ask if that's above or below some threshold, and that's it, and then release the lock.
Right. That makes sense. Yeah.
Um, and then
And then I don't even need, and then I don't, oh, I'll still need the busy state.
so basically what I'm like this busy state is like you're basically just you're basically diffing between two numbers. This is like if you've got like a positive or negative derivative of your number, right?
No, that's not true because I don't mind if it could be 175 forever, but if it reaches 200, I want it to spin back to 150.
Yeah. Okay.
So I'm saying 175 can be busy in one case and unbusy in another case. So it
Yeah,
needs state.
so, yeah. So you've got like a ratchet thing. So yeah,
Yeah,
you first need to like go down to like a reasonable thing.
yeah,
Um, okay.
yeah.
So Yeah, you still need to do like, but this is like more business logic than like the Redis transaction thing. Like you need to like think about like how to model like the thing that you're basically you need to model your state.
Yep.
Um, I mean, it could you could also just save this in like the same variable instead of like doing this like
Oh, you mean like in a string and then like parse it or something? Yeah, you can do that.
yeah, and then you get like the atomicity of like one call to Redis.
Yeah. Yeah, that's true.
Um,
I think in Redis you could also get several keys at once.
oh yeah, that's actually true. You could
Yep.
do that. So yeah, I've been reading a little bit more in like I've been reading the docs in the past few minutes. Um, Redis supports transactions.
Hmm.
So it will not say transactions. It's called like pipeline or multi. Oh, transaction. Yeah, exact pipeline. Yeah, that's the one.
Okay.
Yeah. So as you've got async IO example. Like the first one was like actually um, if you go back to the search, I think like you had a better example, which was async IO transaction something transaction. Async IO examples transaction multi-exec. Yeah.
Okay.
So basically, multi-exec is you're enqueuing commands to run together. So you start by saying basically begin transaction, or and like you would say in SQL begin transaction, in Redis you call that multi. And
Hmm.
then you enqueue some commands to be executed together, and then you say exec when you're ready to run all of them together.
Huh. But if I
So
need to run commands based on state that I get and then set,
so you
yeah.
could write. So you see the Lua scripting thing.
Yeah, that's gross.
Um,
I
but
saw that
that
and I did not like it.
yeah. But basically, this is like so. Think about what you could do is think about how could you change the way you transact with the state in order for things to be as a singular transaction.
Hmm.
Um, so something that would basically you could do like the transaction, and based on the number you get, you know whether you because the things have like you could try to increment something. And then if you get like 201, which is above your like too busy threshold, then you know you're basically raising the something and then and you decrement yourself that back.
Hmm.
You could like optimistically basically update to like above to say +1 to whatever you need to do.
Yeah.
And then you know that thing has happened atomically. And then based on the result of the state you get back, then you know whether you need to actually do something or you should like roll back basically.
Huh. So this transactions, Redis kind of queues them, I guess.
So it queues all of that, and only when you say execute, as you can see, you see the what it says here. It says
Yeah.
pipe.set.set, and then only on the .execute things actually execute. So
No, but
you're
they don't necessarily execute immediately. They execute when the queue inside Redis is clean, whatever it is, clear.
like we could like actually read the docs on like the Redis side, not on the Python side.
Right.
Yeah, it is probably like the better place to actually look at that. But basically, by the way, Redis itself does not support rolling back. It's not transactions as if it's not like a failed transaction on SQL where you actually get like a full clean rollback of the state if you failed.
Hmm.
So yeah, you're basically enqueuing two operations, and then when you say exec, as you can see, you get both these one after the other. But they are both incremented together because you
Right.
know like in within like the universe of Redis, which is basically just one server stored like with or like on running on like one machine, you could lock everything if you wish to do so.
Yep. I wonder, I just have to think more, I guess, about I don't know, the nicest way to do this.
So
Uh,
first of all, like what I mean is this is doing what could fail on the Python side, but actually Redis like at least notifies you that something went wrong.
right, right. This is true.
um, yeah. So like the fact that you could say like enqueue two operations to happen together, and then you get an okay and not okay status on either, you could actually decide like what do you want to actually do now.
Hmm. I feel like moving to the option where I don't have a queue, but rather I just register like a key with a UUID. If I combine that with transactions, I can get like a pretty small Python footprint, basically. Uh, Actually running code. All I have to do, I don't even have to do deckers anymore, right?
Yeah.
Uh, there's
Um,
just a TTL, or I would like to do deckers, I guess. No, that doesn't really solve it.
where you've got like one Redis serving one Redis per model, basically one Redis database per model.
Basically, yeah, we whatever. I prefix everything with the model name,
Yeah,
so
okay, whatever. But what I
yeah,
mean is that also your UUIDs have to also somehow include like the knowledge of like what model is it.
whatever. You could just assume that that's taken care of, but
Yeah. Okay, so in the universe of like one model, which is like Redis works with like prefix trees, basically, right? It's like you
yeah.
could, yeah.
Well,
So
yeah, I guess I should have said that for people who don't know, but basically you could like get a key based on a prefix and you get all of them and you just count them. So you know,
yeah,
yeah,
so yeah, if you've got that, that usually I think that should be fine, especially if you've got like the TTL where you say like whatever, if this hasn't returned in like 5 minutes, then it expires basically.
right.
And then your first of all, like your queue is actually now synchronized with reality. Not like this number is not does not need to exist anymore. And the
Yeah,
only thing that's like you need to basically transact is like around the
the
busy,
busy
not
state.
busy, the busy state.
Right.
Um, and this thing, let's think about whether you can actually have that as something better. I think okay. So what I think you can do is not expire things, but like transition them into like a stale state or something, and then you could actually see like the history instead of like you could like basically um let's think about that. Um you basically if you're on 175, you would like to know if you're exactly on 175. Like have you come to 175 from above or from below, right? From um so if you've got like the history of like what was like the things in the previous time, like in the past few minutes or past few seconds, depending on the performance of whatever the thing that you're doing, you could get
Mhm.
a really better proxy on like this model is actually like actually completing tasks or is it stuck on something, right?
Right, right. That's the goal, basically, right?
Yeah, yeah,
Yeah,
yeah. But this is basically why you're afraid to actually enqueue more work because it's not finishing things.
that's right.
Yeah. So if this is the case, then basically you could actually know like if you keep keys with um, basically um, their timestamp
Yeah,
because right you have like the model slash whatever UUID that you've given it. What are you
yeah.
storing there?
Well, you could do whatever you want. You could store a
Yeah,
timestamp as well,
yeah.
essentially.
So what I mean is instead of like doing this as a by the way, you're almost out of battery. I don't know if that matters.
Uh, no, 14% is fine. Yeah.
Yeah.
Okay.
Okay. Um, but basically, yeah, if you like, you could actually gauge the performance of the model by actually looking at transactions and seeing if they actually finish.
That is an interesting way to solve it, that I don't even need a busy state,
Yeah,
really.
yeah.
Uh,
All you gotta know is you can compute whether it's actually completing at a good rate or not, like the tasks.
then I don't even need transactions,
Yeah,
really.
yeah.
It's lockless completely. Yeah. Yeah.
Yeah. It's basically it's a wait-free algorithm.
What is it?
Wait-free. Wait-free means that you're not locking like. at any actor within like this in this universe of like trying to accomplish something at any point can go to completion on its thing. Like it either decides that it cannot actually perform the action and then returns a 503, or it submits something to the queue.
Right.
Yeah, like
Hmm.
you don't need to wait in order to know what you should do.
Yeah, we don't need any synchronization here at all.
Yeah.
Yep. Any actor can read the state completely from at any given time.
Yeah, I mean, like the race condition here is shifted into whether like a new job has finished before you read the state, and that might shift the rate a little bit. But because you've got like up 200 of them in flight at every given point, then you've got like a good rate thing, and you just need to.
That's that's still an issue, right? So if you get 500 requests at once, then they could all in a queue immediately.
Um, so let's think about that. If they all, so first of all, like each one of them that scans the key space is going to get some amount of like keys back. And if
Right.
you've got like a lot of unfinished keys, then you're not going to, you need to account for that. And like you're not going to, you shouldn't submit yours at some point.
No, that's true. What I'm saying is let's think of clean state. There are no keys at all. Okay, we just
No,
started.
we just started
We
it.
just got 500 requests immediately. Okay. And they all read the key state. They all see a clean key state. Okay. And then they in queue.
So yeah, that's a problem.
Uh-huh. Like
Um,
that's the original sin, basically, for this. That we're trying to solve somehow, then we don't have really a way to solve that.
so
Uh,
as I said, you can have like the Redis distributed lock, and then you
we
could
have a semaphore with more than one. We could have a semaphore for 100 people at once reading the key state.
yeah, you could have that.
Yeah,
Yeah, if you've got like 100 requests submitting, first of all, like because it's Python and you've got like four servers, none of them are going to like patterns.
they have like they have a section about different patterns that you can. Here we go. Several Redis patterns. I don't know if I could find it here. But whatever. Sorry, I wasn't. I didn't mean to distract you.
That's all right. But basically, so the distributed locks, that's the one that you probably want to click at.
Hmm. Right. Okay.
Um,
Okay.
so yeah, so you've got
And
the
it points
Reddit.
to a bunch of libraries, but that's not interesting. But yeah, but I guess the only question, it'll be very easy to answer if we see in the lock like some kind of number. Yeah. When you create the lock or acquire it or whatever it is.
Yeah,
Um,
so blocking name thread local.
locking. I don't see what I'm looking for right here.
So you could also try to look for something like I cannot like only showing yours, but you could say like Redis semaphore instead of
Yeah, and I'm sure that exists. If not as a library, then as some
counting semaphores. Oh, you've got that on the Redis docs. Yeah, that's the
a
one.
block. Oh, there we go. That's great. That's what I really want, I guess.
Yeah, redis.com counting semaphores. Okay, so
There we go. Yeah. I wonder if, oh, I guess they didn't implement it, but I assume there's a way to do like raw stuff.
yeah, but
Uh, yeah.
basically, I believe like Redis should give you like this low-level synchronization mechanism because you so desperately want to implement your own things. Um,
Yeah. I said we're just trying to have fun. So,
yeah, yeah, yeah. So basically, you should have like yeah a semaphore thing, like some way to transact over a semaphore.
mhm.
Um, so by the way, you could literally just use a lock, increment a counter, look at the counter, and see whether you can submit something to the queue or not.
But
And then
like
and
we
then and no,
see,
and then once you've got and then when you're like in around the whatever 100 and something area, and you know like your model is almost saturated, that's where you could basically just decide whether you'd like to submit something based on the rate of how the model is actually completing the jobs.
Yeah.
Which,
Right.
yeah, I mean,
Right.
once
You don't have to be interested. You don't have to be interested in that state if you know that you're in like a very early, like a very low usage of the model for sure.
yeah,
Yeah.
basically, yeah. If you're below whatever that's like the 150 threshold, then you can
Yeah.
just submit something. And
Yeah.
then if you're above that, and then you should like look at the rate, and then you can decide whether you want to heuristically decide whether the model is too busy, and then you can just raise the 503. And
Yeah.
if you're above, then you don't submit anyhow.
Mhm. Okay.
And then you don't have you're only transacting over like one number, which is basically the thing. And you could but basically by the way, like you've got like a small problem here, which is the number is now sort of disconnected from the actual count of the key space.
You're saying the semaphore number?
The semaphore number, yeah. So the semaphore actually can only the semaphore can only be like for, am I allowed to scan the key space?
Yeah, that's all I'm looking for.
So yeah, so the semaphore doesn't even need to be a counting semaphore. It can be like literally just a binary lock.
A binary lock.
I mean, just a lock. Just like one submitter is allowed to scan the key space at every given time. And
Yeah, but I
because
don't want that. I don't want only one submitter to be able to look at it.
so you're okay with like some noise around, like a small amount of race around the submission of the jobs to the queue.
Yeah, exactly. Just not an enormous race. That's the issue.
Okay,
Yeah,
so if
because
that,
I don't mind because these thresholds are, they're arbitrary. They're not arbitrary, but they're somehow heuristic, just like you said. I don't
yeah,
care if we're 20 above, but we should never be 500 above. Yeah.
yeah. So in that case, then yeah. By the way, like it's also like very likely that you can assume that 500 concurrent requests are not really concurrent, and like they will basically they will serialize in some sense. They will be,
Of course, they're so, right. They won't actually literally be concurrent, but even we don't want 100 requests racing. Even
uh,
I'll take 20, like we said. Yeah.
so like, by the way, you could because you've got like fast API here, you
Yeah.
could have an async IO lock on each on each server, and then in each server, only one request is allowed to introspect the key space at every given point in time, and then
Yeah, but
you
then you're limited to a pretty small amount of
not really. I mean, like you're asking Redis to give you the key space that should be like very small and very fast, and that's not
hmm.
where you're actually introducing latency to the system.
No, but I think each server may have 10 or 20 or 30 requests concurrently, real
Yeah,
requests. Yeah.
yeah, I know. And then they will serialize over like whatever
Let's talk
like
about worst case, I guess, right?
yeah. So first of all, like why don't you spam your Redis now with like 1,000 keys, and
Yeah.
let's actually benchmark on like a really jank ARM, not jank, but that's an M2. But anyway, like
M1.
M1. Okay, but I mean an M1 core on Redis on Docker. How fast is it? Like how fast is it to just give you the cardinality of the key space?
Okay, okay. So I wonder if there's like a count. Is there a count or do I need to do it manually somehow? Um, Number of times an item may be in the key
Range, maybe?
range. Okay.
Range count. Yep,
This
I think so. Let's look at that.
query a range in forward direction for a specific time series.
No. Okay, never mind.
Redis count
Keys.
keys with prefix. There we go. Okay. How to count the number of keys matching the
Scan.
pattern? Scan? P call? What the hell? Keys.
Oh,
Yeah,
yeah,
that's what I want.
yeah.
All right. Very nice. Okay. So you're saying let us. Oh, I have my another Redis desktop manager. I wonder if there's a way to bulk add keys. Oh yeah, yeah, yeah. This is why I love this so much, and I used Open Collective to give them money. Um, how do I do like a set? Is there a way to do like a bulk set somehow?
Set range, key offset value might do the thing.
Okay, okay.
I'm not sure. Like,
Key offset value. All right. Let's say K.
no, 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 no. That's for setting like an item within the list, a list. But
That is
um
set
you could
bulk.
use Python and just write a loop like and then insert.
Yeah, but any time I get a chance to like inspect a CLI, like a syntax that I know less, I guess that's less for the stream, but
Yeah.
more for me.
Basically, you could define like a new endpoint, which basically just inserts 100 keys, and then we could you could curl that, and that would mutate everything.
Sounds reasonable.
Yeah. And especially like just you need to delete like anything that's like not the Redis connection.
Yeah.
And yeah, for I and range 1000, whatever. Then
Wait. I should, whatever. That's fine. It's
yeah,
fine. It's fine.
yeah, Redis set
Set
and give it a prefix, please. Yeah.
KI and that's it, right? Oh no,
Yeah. Uh,
value, whatever. Yeah. And okay.
Actually add like a proper values, so we'll actually see like things. Maybe I don't know. Yeah, I should be okay.
Yeah. Um,
You should
okay.
save because it's VS Code, or is it okay with
No, I
saving?
think I have autosave on. So
Oh, spam.
yeah, I might have to tell it to do post minus X post that I was done, right?
Yeah, probably.
Nice.
Yay!
Uh,
Terminal.
It's
Yeah.
input should be a valid string. Oh, what? Oh, yeah, 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 yeah. It's kind of stupid that way, but I actually like that it's dumb, honestly. I don't like the whole coercion and stuff. I like that it forces me to actually do that. What's the problem now? Input should be a valid string. What does it want exactly?
Um, ESET. Oh, wait. Is it actually hanging on the thing that you're looking at?
Let us destroy everything here. Whatever.
Um,
Uh, await app.
I
Where
think
is there
that's
an
okay.
await app?
So run that again.
Okay.
Where is it? It's on the fast API routing thing. It says
Oh, I
you.
didn't give it a string. It tried to serialize
Yeah, yeah.
nothing. That makes sense. That's fine. Okay. Not very descriptive, but whatever. Oh, I guess we must have done it like 1,000 times by now. So, yay. Oh, I'm so stupid. I'm so stupid.
You
I
haven't
want
done
to do
the colon.
no,
Uh,
because yeah, and the it even knows to
there
yes.
now it will split it by directory. Yeah.
Yeah.
So you
Well,
should.
whatever. Yeah. Okay. Where's our G? Where is our
Okay.
G?
Yeah.
Go.
Oh, awesome.
Okay.
Okay.
Now we
So
want to check how long it takes to enumerate it, right?
yeah. So we just say keys on G. Yeah. And we could literally time like use the Python's performance counter.
How do I do that again?
From time import like time yeah, performance counter, I think. Perf counter,
Nice.
sorry. Perf counter at nanoseconds is nice.
Yeah, why
And
not? Okay.
then we've
Now we're
got
going to await Redis dot keys, hopefully. Keys.
yeah,
Nice.
keys and yeah,
G
G colon, yeah.
star, G colon star, I guess.
I'm not
Uh,
sure. I think you don't even need like the star, or maybe actually maybe you do.
it's nicer.
Yeah, okay. And you just need to also
Oh, nope, not what I meant to do, but whatever. Read. Oh, we have to do the perf counting. That's true.
Yeah.
Let's just see what we do. Okay. Wow, that was really fast.
Yeah, Redis is fast.
Okay.
I mean, it's all in memory. That's the whole point. Like, and it's um,
Oh, I
y-
guess I have to get this. Okay, so
you should say
start.
start. Yeah, start. Yeah, perf counter. Then
Uh,
you
wait.
should
Oh, interesting that it returns all the keys. All I want is to count them. Is there a way to do that? Uh,
maybe on the docs it will say something. I'm not sure.
Now I want to just print.
Not print. You want to return this as the request, and then you will see that in
Oh,
terminal.
okay.
Then you could
And
say
then I want
like,
to do perf counter ns minus start, right?
yeah,
That's all.
it's a function call. You need to line 35 is incorrect.
Yep.
And yeah,
Okay.
and printing is probably not what you want because like you could, don't you want to
What is
return that?
a list keys? Response T. Oh, because it's a async. No, didn't return anything.
So yeah, you didn't return. That's what I said.
Print.
You should, yeah, say
Yes,
return,
you're
and then it will.
really correct.
You could just remove the type hint, and then whatever you return is going to be fine with Python with the fast
Yay.
API.
But we want to do this like times something that's human readable.
Yeah,
By 1,000, divide by 1 million,
by
really.
1 million, and yeah, I think
Oh, let's see. How many Ooh. Oh,
it's not an
I
int.
guess like
It,
this.
it's not an int. No, no, no. This is a int div. But what I'm saying, you're returning a float, and then Python is again angry at you.
Yeah, yeah. But this is isn't
No,
this
yeah, that's a floor div. Yeah,
okay. Nice. Okay. So that's how much? No, that's microseconds, right? Really, I want
yeah.
milliseconds. Okay, there we go. That is all right. It's pretty quick, honestly. Yeah.
Um, yeah,
You know, if I put a TTL on the keys, then it won't be infinite, and that's fine.
yeah, and you should put TTL on the keys. That's part of the task management
Part of the Redis
thing.
experience. Yeah.
Yeah.
Yep. Yep. Okay. Okay.
And this is, by the way, by the way, do you have the Hyperfine on this computer? Hyperfine is a benchmarking thing.
This
Yeah.
it's almost all noise. So 6 milliseconds basically is
Oh,
getting the keys. So I
yeah.
wonder if there might be a way to do that just without just counting, right? Key space, read, slow, dangerous. Okay, interesting.
Because it's an O of n complexity, and if you're scanning star, then you're sad.
I guess. I wonder if that's what makes it dangerous. For slow, I understand, but
Consider using scan or sets. What
okay.
are actually sets? Sets are an interesting construct that we haven't thought about.
I,
If
I I don't even know what Redis sets are. I just saw that they have something, but I don't even know what it is.
so, let's actually. I think this is a very interesting. Okay, track unique items. It
Hmm,
seems like what you'd want, maybe.
that's fine. That's true. Represent relations. That's not interesting, but I wonder if it has count. Oh,
So
that's amazing. Size. Yes, please.
yeah, so you've got a set add set remove,
Mm-hmm.
and I think that is all you need to have. Like you've got the cardinality, you've got your way to commit into the set and get things out of the set.
Right. Okay. So let's go over the solution so far for the lockless, cheap, well, cheap in some senses, cheap if you're lazy to read documentation of celery or something.
Uh, uh,
Um,
yeah,
uh, okay. And we said we're having fun, so let's have fun.
yeah.
So we implement it by we just commit a key like a whatever a UUID with a timestamp for
Uh,
each
yeah, you could
print,
literally
right?
use a snowflake, like a really something that's bound to a timestamp, then it's also sortable, and then you can actually see like what is the actual performance per request.
Exactly. So we no longer have a busy state. Either way, we have a TTL on the key for whatever, 5 minutes, 10 minutes. That's like an aside, basically.
Yeah, yeah.
So then each request that comes in, it um, reads the cardinality of the set of the pattern of the requests that
Of the
are
model, yeah.
that are up, and then what do I say? And then I need to understand basically if but then does that mean that I don't need the busy state anymore at all? We don't have a counter, we don't have a busy state. How do I still use the two thresholds, or is that something that we decided
So
that we don't need to do anymore?
if it's low cardinality, you just insert right away. You don't think about things. But I'd say actually fetch the whole, not queue, fetch the set basically.
After reading the set size or not
So
reading the set size?
so if it's really low,
Yeah, if it's like under 50, then you could always just, let it
yeah,
go.
yeah. I mean, basically, we're trying to hedge our bets with like data races right now.
Yeah, yeah.
Okay, so if low and queue. Um, yeah, low fuzz. Yeah, like small data races allowed basically. Um,
This is just
uh,
to send from like thousands of requests at once, basically. So,
yeah, if you're semaphoring, then you can like just if you're already semaphoring, then just fetch the whole set and actually compute the rate.
hmm.
I mean, why not? You get the count for free, and you can just enqueue, and I mean, you're already doing the expensive thing, which is to lock state in Redis.
Yeah, okay. I mean, it
Uh,
doesn't have to be a set then if we're doing that. I could just enqueue and like add in, create and delete. Like, what do I care? Um,
okay, so if low and queue, if like above whatever, like yeah, compute rate based on timestamps. So yeah, UUID plus the actual timestamp is like the thing that you actually want, of course.
yeah, I don't see why I shouldn't use Snowflake. That's fine. Okay. It also
Um,
signals to someone reading what I'm trying to do, which is nice.
yeah.
Uh, okay. If high
Uh,
compute rate based on timestamp
and
and
then yeah,
and
and then if rate like yeah, balance if busy, basically. Yeah. Otherwise in queue.
and otherwise we want to either way we want to like in queue Snowflake. Right.
Yeah.
Okay. That's fine. All right. Sounds good. Sounds
Yeah,
good to me.
the only thing that's missing here is making sure that set elements can have a TTM.
Right, right, right. That's just a nice feature to have, and also kind of again coding against our own sanity, basically. In Q
Uh,
Snowflake, TTL 510, whatever.
um, yeah, I mean, like this rate thing, you just need to make sure that you're actually like this is a bug prone thing, basically.
The
But
what?
like computing the rate, that's the only thing that you need to make sure that like
Yeah, that should be tested for sure. Either way.
yes, that's like
Yeah,
the
it should be as dumb as possible, I assume. You know.
yeah.
Uh,
I mean, the fact that you're doing like some kind of like algorithm, which is like non-trivial, is that might be like I feel like this is dangerous. I'm not sure if I fully support my own advice here.
Look, if the algorithm is just if you see in the last 3 minutes 100 requests, I mean that's pretty simple, right? Or 1,000 or whatever it is, or configurable.
Yeah.
That's quite simple. And if you test it that you're reading snowflakes correctly, then that's basically all you have to do, I think.
Yeah. So you just have to make sure that you're actually like you can extract timestamps back from your snowflakes correctly,
Yeah,
and
basically.
yeah, the best way to have that is probably like yeah using like a library that actually does this for you.
If pi snowflakes exist or whatever it is, I'm sure it has that.
Yeah, like Snowflake specifically, I think is literally deprecated, and then and I think you've got like Snowflake 2 or something like that.
Okay, we could just look at it for a second to see snowflake connector. What?
No, 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 no. Uh,
Snowflake. I'm not sure. Workloads?
It should be a workload. Look up for Snowflake ID. It is, by the way, it is a truly hard problem. Like there is no easy solution. Usually what you do is usually you outsource the hard solution to someone else who already thought hard about that.
Yeah, but even then, your logic leaks into the solution, or the solution leaks into the outsourcing, right?
So usually what you can do is like you could like a good solution provider basically has a really good way for you to plug in your business logic into the whatever distributed solution that you need.
Right.
Yeah. Like usually you do have like a way to condition and like it's not like you're not just like blindingly enqueuing things. Uh, that's the whole point. Um,
I think the more parts of your solution, maybe this is an illusion, but the more parts of your solution that you can solve waitlist or like without synchronization, the less the less you'll have to deal with those leaks. But I'm calling that an illusion because it might be that the parts that you're leaving over are the actual, like whatever. Uh, you can't necessarily, there's no way to have a foolproof uh, solution without understanding what's actually happening, I think.
um, so yeah, but it's not that it's foolproof now.
No, it's definitely not foolproof now. Yeah.
Yeah, so like basically if you're now like moving the goalpost for the external solution and you're saying that this one needs to be better than mine in terms of like being completely foolproof, then that's not fair towards that solution.
No, it's not fair and it's not a realistic goal really, especially not for this task. It's not
Uh,
realistic, it's not necessarily necessary.
yeah. So I mean, in this case, yeah, as I said, probably like having like a really small task queue would just do the thing.
Yeah.
And if you use something like prefect, then you also like have actual Python logic before you actually submit the task into the LLM, which is actually a good thing.
Yeah.
Um,
I looked
RabbitMQ,
into it. That sounds pretty cool. Yeah.
yeah, prefect is nice. Like, and they have like their own dashboard where you can actually like see the metrics of like what's actually happening.
That is also cool. Yeah.
Yeah,
Having some insight live is pretty cool.
yeah. I haven't deployed the prefect in production yet, so but from playing around with it, it was fun. As I said, just make sure that things are working because it may be like not executing the things that you think it may be executing. This is like the only thing that like worries me that is the fact that I see like I've submitted some tasks and then they took 2 seconds to start, which is not unacceptable.
Yeah, that's too much.
Um, so you just need to make sure that this is not happening. Okay, have a great night. Thank you very much for joining me. This is fun.